All right, welcome back to our last session of Creation Weekend 2025. Just a reminder, the slides are up here on the screens. If you have less than absolutely perfect vision, you may want to move forwards. There are plenty of open pews. Come on up. Secondly, if you would like to help support the work of Creation Weekend that we do here at Calvary Bible Church every year, we do have our standard collection box out in the foyer. If you would like to make a donation to doing this so we can continue going with Creation Weekend in the future, please do so. Or contact us if you want to do something else, and we would love to work with you on that. Also, just a reminder, there are some fantastic books out in the foyer. Tonight's probably your last chance. If you would like to pick one up, get your wallets out. Go home with a bundle and read them all. So tonight is our last session, and I would like to welcome, I don't know that we need another introduction. We've been here now 5 times. So let's welcome Heinz back up as he shares about our privileged planet.
A fifth lecture here, fifth message, and this is one again that hits on design versus evolution, intelligent design. I'm going to go through some of those terms and explain how they all relate to each other. But the topic tonight is on our privileged planet. In other words, the Earth is privileged because it can support life. There's no other obviously no other planet in our solar system that supports life. But of course, people are looking. They want to find life in another planet. And this will cover some of the features that you need in planets in order to support life. And the probability of getting all those things right is approaching 0. Okay, so we're in a very special planet. That's why I called our privileged planet. So again, I showed you this chart with chance, necessity, or design. I discussed that a few times already. Going to go through how do you know if it's designed. We're going to look at the Earth's location in space, laws of science in the Bible, mathematical probability, and something called the anthropic principle. And that is the Earth was designed to support life and specifically to support us as humans. And so we'll look at why that is so special. And then there is a search for other planets. People are always looking for something new that's not covered in the Bible. And then the conclusion is Earth really is our privileged planet. This here I showed you before. Everything can be explained by one of 3 ways. One is that it just happened randomly. The second, it's a law of nature that requires it to happen that way. And third, if it's not one of those, then it's designed. And that could be designed, by humans. These chairs, they didn't happen by chance. There's no law of nature that would require it to be like that. So there's a craftsman who designed that and built it. And that's design. So I'm going to talk now about the difference. You've heard the term intelligent design before, but I'm going to look at that in light of creation and evolution, and you can see the difference. Creation, of course, is by the Bible. God created the universe and all life according to its kinds, and we've been through that this weekend already. And then the evolution is different. And when we talk about evolution, remember there were 5 definitions of evolution, and you shouldn't confuse one with the other. We're talking about macroevolution. In other words, going from one kind of living organism to another kind, cat to dog or dog to cat or horse to cow, or that just doesn't happen. But Darwin's theory of evolution is there was life started from one simple cell, and then the cells duplicate, and then they mutate, so there's mutations and there's selection, and so when the reproduction happens, there's selection from the 2, the father and the mother in this case, in humans, And so everybody looks different. And then is common descent. In other words, life started from one cell, and everything else that you see living is from that one cell. It's related. So, and that the definition is that this is what we mean by evolution. And that has really, there's books out there by Dr. Jonathan Sarfati from Creation Ministries International. He wrote a book, Refuting Evolution, and he actually wrote the first edition back 26 years ago. And that's from Creation Ministries International. It's creation.com on the website. And they have sold more than 500,000 copies of that book. And the 6th edition of the book is out there. That's the latest one here. Okay, so evolution, as far as I'm concerned, as far as he's concerned, it's been pretty well disproven. It can't work. It doesn't work because there's no evidence for it. And then you've probably heard the term intelligent design. There's an organization, the Discovery Institute in Seattle, who really publicized this intelligent design. And all it is that when you look at something that appears to be designed, there's a designer behind it, whether it's another human being that designed that, or in the case of life, we believe the designer is God. And then we're going to look at some of the, how you know if it's designed. And I'm going to explain these two terms, irreducible complexity and specified complexity, because that defines intelligent design. Many intelligent design people are believers, but some are not, okay? So telling if something is designed, two big things. One thing is irreducible complexity. What does that big term mean? And I can best explain it by looking at this mousetrap. You've got 5 parts of the mousetrap. They all have to be on the base of the mousetrap, include the platform itself. All 5 things need to be there to catch any mice. Some people said, no, you're wrong. You need something else. You need a piece of cheese as well on there to entice them to come there. But the point is, if I take one of those things away, it doesn't work. That's what those words mean, irreducible complexity. In other words, this is down to 5 parts, and you can't go down any more to 4 parts because it doesn't work. And then that is the same for, in our body, we actually have motors running. You can't feel it, but there are molecular machines in our body, in our cells, and they are rotating, and they look something like this box to the right, intelligent design theory. And some of the pieces of that look like you're used to when you look at mechanical things. They have wheels and motors, for example, and they are very special. They're very, very small. Obviously, you can't see them unless you take it all apart. And so that's an example of, and in that case as well, all the pieces on the chart in the middle there have to be in place or else the motor doesn't work. So that's irreducible complexity. And then the second thing is specified complexity. It is complex. But so let me just take an example. Specified complexity. I can write a sentence in English with a noun and a verb and adjectives and all that, and you can understand what that is. But if you have a sentence of, let's say, just 6 words, the letters in each word have to be in a specified order in order to be meaningful. And then the words have to be in a special order in order to have a sentence that means something. And so the same thing is true of our cells. We have DNA in our cells. You can see in the bottom right chart there. And the inner workings of the cell are very, very special and complex. And so there's information in the DNA, and that is what provides the intelligence. Information demands intelligence. So, the only thing that differentiates a life from a non-living material is information. If we didn't have the DNA, we wouldn't be living. It's the DNA in our cell that makes it all work. And as I said earlier, there are programs in there that work in your cell. The DNA is programmed to duplicate in special ways. So there's a program and there's data, and that is the information that's required for life. So the design inference, the inference of design requires an intelligent source. Our experience tells us all man-made information systems and complex machines have an intelligent origin. And obviously these machines that we're looking at are designed, and that takes a designer. It takes an intelligent origin. So we infer that biological systems also require an intelligent source. And so we have what they call a design filter, which I'm not going to go through in detail, but this is how you decide how it really was designed. You check to see if it's random first, if it's not random, and then you look to see if it's a law of nature that requires it to be that way, or else it is designed. So the evidence tells us then that what we need is these two things at the bottom that I specify, the irreducible complexity and the specified complexity, but you also need biological information, and that's the programs in the DNA. So those three things are required for life. I think in a previous lecture this weekend, I covered this. How do you tell the difference between chance, necessity, which is a law of nature, or design? You look at the top left and you see scratches on a wall in a cave. How did they get there? Well, it could be rocks somehow, leaving those cuts there, leaving those marks, but it could also be just, random. Hard to tell. But if you go down to the bottom one, you'll see pictures of animals on the wall, horses and cows and pigs and, imprinted on the cave wall. Obviously, that did not happen by chance. There's no law of nature that requires that, so there's a design behind it. A designer did that. Okay, and the same is true of our human genome. The complexity is astronomical. It just can't happen by chance. And the cell is very complex, and we have 75 trillion or so of the cells in our bodies. So that doesn't happen by chance. And I also covered this one, I think, before, how do the evolutionists respond? I mean, the evolutionists, they know all the things that I'm telling you, but they can't accept what it means. Here's one, Dr. Todd from Kansas State University said, even if all the data point to intelligent designers, such a hypothesis is excluded from science because it is not naturalistic. Okay, because they believe that nature is all there is. And then this famous atheist biologist, Richard Dawkins, he said, biology is a study of complicated things that have the appearance of being designed for a purpose, but he can't accept that. There has to be another explanation according to him, but there is no other explanation. And the same thing with Francis Crick, the co-discoverer of DNA. He said, biologists must constantly keep in mind that what they see was not designed, but rather evolved. Okay, so then we look at our location of our planet, Earth, which is the third planet in from the sun. The sun, Mercury, Venus, Earth, and Mars, And then you have an asteroid belt which protects us from some radiation in space. Saturn and Jupiter are gaseous planets, and they have something to do with protecting us from some radiation in space. So we're fortunate to have that. And there are comets out there. Poor Pluto used to be a planet, but some people said, well, maybe we should bring him back as a planet. But anyway, that would make it 9. So this is where we are in space, and then we have a huge sun around which we obviously orbit. So what makes our sun unique? Well, gravity. The gravitational field holds our solar system together. I mean, if gravity wasn't acting properly as we orbit around the sun, we would just fly away from the sun. I mean, it's gravity that keeps us in an orbit, in a specified orbit. Source of energy and light for life on Earth. That is the only source for light and energy for us on Earth. And so it's obviously very important. So it also generates a magnetic field that envelops all planets in the solar system, and that helps protect us as well from radiation. The sun's heliosphere, the sun is at the center of a heliosphere, acts as a giant shield protecting planets from galactic cosmic radiation. So we have the structure that protects us from radiation out there as well. And it emits precise range of color making, photosynthesis possible, which is what plants use, of course, to live. And some people would say, and we would conclude here as well, that Earth is in what they call the Goldilocks zone. In other words, we're the third planet in from the sun. We couldn't live on Mars or Venus. Either they're too cold or too hot, so we can't. So that makes Earth in the right place. Sun size also controls the size of tidal waves on the Earth. The moon does as well, but the sun also has a part to play in that. So some facts about astronomy. Astronomy, of course, is the science dealing with the study of the sun, the moon, and the planets and the stars. And the solar system is a star, or the sun is a star, plus its 8 planets. And when we talk about the solar system, those are the pieces that we're talking about. And stars are parts of galaxies. As I mentioned earlier, there are, scientists think there are about 100 billion different galaxies out there. We live in the Milky Way galaxy, and we're a very small dot part of that. And there are about 100 million stars in each one of the galaxies. So we have a huge number of stars, which is incomprehensible and can't be numbered. And the universe consists of, well, this 100 billion galaxies and 100 stars, billion stars per galaxy. The solar system is part of the Milky Way galaxy, and we are what they call a spiral galaxy. You see in the bottom right there. And I've got, well, not here, but I'll show you in a bit where we are in that. Andromeda is our closest galaxy, and it's 2 million light years away, way far away. We'll never get there. We can see it with a telescope, but we're not going to get there. And our closest star is 4.5 light years away within our own galaxy. So here is what the latest telescopes show the galaxies and stars in the universe. Psalm 19:1 comes to mind. The heavens declare the glory of God. So all of these stars and galaxies, they look brighter than they used to because we have a new James Webb space telescope that can look at this in much more detail than the old Hubble space telescope could. Okay, and here we are. We live in a spiral galaxy, and so we are between the two arms here in the galaxy. I think in the next picture, yeah, here. So here's the spiral galaxy, and the sun is a dot in this picture here. So it shows you how small we are relative to the Milky Way galaxy. Most of the planets found to date lie within 300 light years from our sun. So even the other planets, other than those in the solar system, are way far away. It's very hard to study them. So we're in a very special place where, in fact, you can see these arms, the circles there. We are actually between two circles, or we're in a very protected region of the Milky Way. So now I want to talk a little bit about the laws of science and how they agree with what the Bible has to say. I'm just going to look at a few here. First of all, remember in the book of first chapter of Genesis, we said God created all life in the first chapter of Genesis, and God created the beginning of all life, all different kinds. He created, as stated in that chapter. So there's a law of biogenesis which scientists have discovered I guess the 1800s. Pasteur came up with the law of biogenesis, which states that life comes only from life. There is no abiogenesis. In other words, starting life without having a previous life. So God created all the original life, and we came from one of those kinds. Second law here, the first law of dynamics, which states that it's conservation of mass and energy. That's a well-known law that governs our universe, and this is Einstein's equation of energy equal to mass times the speed of light squared. So, and that is constant. And what does the Genesis say? In Genesis 2, verses 1 to 3, it says God created everything, and then in Genesis 2, he says, and everything was finished. God finished creation, and so there's no more energy or mass created since then. You can change mass into energy, or you can change energy into mass, but there's no more net production of mass or energy. So those verses agree with those two laws. And then the second law of thermodynamics is the law of entropy in a closed or open system. In other words, what that says is spontaneous processes lead to a decrease in order. Everything is running down. And if you're asked to clean your bedroom, every week, why? Because it's getting more and more disorderly. And so you have to bring it back into order. So everything left on its own, that decreases in order, and it decreases in the amount of energy that's available to do things. So things move in a direction from order to chaos. And so this law is very important because if we didn't have a beginning, for example, let's say the universe existed forever and things were running down, we could be run out of all available useful energy. So we know from that second law of thermodynamics that the universe had a beginning. And that, of course, first chapter in Genesis tells us that as well. And then the fourth one, for every effect that we see, something causes it. It just doesn't sort of happen randomly. So every effect that you see must have a cause, and the effect cannot be greater in size or kind than the cause. So that's those four laws of nature, Genesis and Romans here, those verses agree with that. So what are some other laws of nature? Well, nature is bound by laws. If you read Jeremiah 33:25, God made nature, God made his universe with fixed laws. The law of gravity is what it is. It's fixed. It doesn't change over time. All the laws are fixed. So necessarily, physics is fixed. What if you woke up tomorrow and the law of gravity have changed? You'd have different behavior. Chemistry, the way things bind together doesn't change. Mathematics is fixed. 2 times 2 is equal to 4 all the time. And laws of life and logic, they're rational. Universal constants, we'll get into that. The motion of planets. There are constants which are fixed at certain values which are important that make life possible. And they're uniform throughout the universe. So they're not just true here on Earth, but they're also true on the moon. Even though on the moon, the pull of gravity is less because the size of the moon is much smaller than the Earth. So the consequences of, because we do have laws of nature, we can surmise that we also have a lawgiver. Laws don't just happen to be what they are. Somebody designed those laws. There's a lawgiver. Laws of nature are consistent with creation, and the laws of nature make science possible. You couldn't do science. You couldn't study nature. You couldn't study our Earth or the sun or the planets if the laws weren't fixed. If you ran the experiment the next day and things changed, the world would be a mess. And in Jeremiah 33:25, the ordinances of heaven and earth are fixed. And then we even have the laws of logic, transcendent truth, dependent on by the laws of nature. The laws of nature are what they are. We have a law of contradiction, of non-contradiction. Both A and not A can be true at the same time in the same relationship. I can say, my wife is not in the room, but I have to qualify that by saying she's not in the room now, but 5 minutes ago she was in the room. So it has to be the same time and the same context. So God does not contradict himself. So this makes reasoning possible. God says in Isaiah that we can reason together. So because God is logical and we are made in God's image, and so we can be logical as well. So because we reflect God's nature. So if you ask the evolutionists or the secular scientists, how would he explain this? How did they come to be that these laws of nature exist? Where did that come from? Could they have evolved from something else to come to the fixed nature that they have today? I don't think so. A little bit more natural laws. The first 2 laws of thermodynamics are constant, as we discussed. The entropy of a system increases over time. And what that means is that the disorder increases over time of every system. Other constant laws include law of gravity, conservation of momentum, conservation of electrical charge. And so how did these laws come to be? Did they evolve? Did they change over time? No. God created them fixed, and they're always what they were at the time of creation. So a little bit more about the law of thermodynamics, because this is very important. It explains how things operate in the world. And I'm not going to go into a lot of detail, but you start with an energy here on the left, and you have heat generates in a machine, mechanical energy, and a generator, and you end up with electrical energy. The second law of thermodynamics, increasing entropy. And entropy, think of that as unavailable energy, which you cannot use now. So what that means is that everything goes from order to disorder if left to themselves. unless you do something about that. Now, so the second law of thermodynamics is at odds with evolution, because remember, evolution assumes a big bang. So there was nothing exploded, and then we have chaos. If you explode something, it's chaos, and so so evolution requires you to go from chaos to order. But we see that that's not how the world operates. The world operates by decreasing, going from order to disorder. So that's totally in reverse of what the second law of thermodynamics is. And things go from, in terms of life, they would say there was a first cell, and then it duplicated, and eventually it mutated, and natural selection created another species, going from a simple cell to a much more complex living being. So that's not supported by the second law of thermodynamics. That's against the second law of thermodynamics. So it's an uphill battle. So what do we observe in nature? Order goes to disorder. In other words, things deteriorate. There's less energy available over time and increased randomness over time. And we see that. Things left to themselves, they deteriorate. So evolution requires something else for it to happen. So what does that mean? We have an energy supply. We have the energy from the sun. And in terms of living things, the sun comes down with energy, and the plants take up that energy. They can store that energy, but how do they convert that into living material? Well, there has to be something a process that does that, and that's called photosynthesis. So the living plant takes in that energy. There's a program of some, in the seed or whatever started that plant going, and with that energy acting on it, and the program in the seed knows how to grow that plant. So there's a program. So there's a mechanism, first of all, for storing that energy from the sun, and then converting that incoming energy to life in that plant. And so the program working on that information directs the growth in the organized complexity. So that's for living things, photosynthesis. And in that case, you go from a seed to a plant. And in the case of an animal, like this cow here, again, the cow, of course, they feed on the pasture, and they have green plants that they eat. So they can just take that in, but then they have to convert it into an energy that helps them to grow. And so that's step number 3 and 4 again. In terms of animal growth, there's animal metabolism, and then energy composes the diet for the cow. So again, we depend on the energy and light from the sun for growth in plants and animals. Okay, a little bit of history on Christianity and modern science. I showed you this morning too that a lot of the disciplines of science actually came from Christians who believed in the Bible, Bible-believing Christian. That's why I say modern science originated in Christianity, because our belief system supported the scientific method. And so the universe is governed by laws, and that requires a lawgiver. Isaac Newton, one of the scientists that we talked about this morning in the 17th century, here's one of his sayings: "The most beautiful system of sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being." So he recognized that God was the creator. He created the system that we live in. And Isaac Newton was the discovered the law of gravity and the three laws of motion, referred to the Newton's law of motion. And then we have another scientist, Johannes Kepler, who came a little later, saying the universe is knowable to our minds. We have a rational mind. We can think. And what Johannes Kepler said, he said, the chief aim of all investigations of the external world should be to discover the rational order that has been imposed on it by God. In other words, he said, thinking God's thoughts after him. So he wanted to discover how God created this universe. And so God has given us the ability to rationally think and how things work. So we look at the evidence for that. And of course, today we have telescopes that we can see further out in space. We have microscopes that we can see real small living organisms. And so we have the ability to study a lot about what God created. Some of you in school, maybe if you're out of school, you forgot about the periodic table. But this is the periodic table of all the elements that are in our universe. And you'll notice that it's colored. And why is that colored? Well, Dmitry Mendeleev, a Russian, he looked at all these elements and said there's some commonality between them. There's a set of rare earths, a set of alkali metals, let's see, and noble gases. Those are related, like helium, neon, and argon, krypton. These are the far right is all the rare gases, and so there's some order in the element table, the periodic elements. So they, again, another sign of design. So now, how many people like to do math here? How many people know about probability? Have you heard that big word, probability? What if you have a dime and you flip it up? Which way does it land? Heads up or tail? Could be either one, right? So what if you flip it twice? Yeah, it'll go one would be tails, one would be head. But if you flip enough times, what's the probability of getting, let's say, 4 of those flips to be the same? 2 heads in a row, 3 heads in a row, and 10 heads in a row, and you go across there. That is 2 to the power of 10, which is 1024, and that's 1 in 1,000, 10 to the third, roughly. So this is how we measure probability. What's the probability of throwing 100 heads in a row? How long would it take for you to do that? More time than you have. And 1,000 heads in a row. We're up to 10 to the power of 300 now. Okay, one chance in 10 with 300 zeros after it. What's the probability of doing that? 0. And that's the law of probability says if anything is less than 1 in 10 to the power 50, in other words, the exponent there, 300, it would be 50. Anything less than 1 in 10 to the power 50 is mathematically impossible. So if this number 300, say, which is bigger than 50, but if that were 1,000, for example, there's no way that could happen. Even if it were 200 or 100, it just cannot happen. So that's what we mean by mathematical probability. So we'll bring that into play later. But so then we come to the anthropic principle. What do we mean by that? Well, that's a principle that states that the universe appears to be carefully designed for the well-being of mankind. The anthro is, according to man. So what's the probability that the universe could be designed by us, designed by God so that we could live on this earth, what would have to be true? What are the values of some of the constants? So we see some evidence in nature of this. You recognize this as the atom, this picture here, with protons and neutrons in the nucleus, and then the electrons orbiting around the nucleus. The mass of the proton by itself is very precise. The gravitational force is very precise, and the strength of electrical charges also is very precise, and we'll see what that means. Another question people ask, how possible is it to have a total solar eclipse? What does it require to see a solar eclipse? Okay, there are more than 100 precise universal constants in our universe that are precisely exactly what they need to be to support life. All of them have to be exactly so. The role of gaseous planets like Saturn and Jupiter. So the mass of the proton is chosen for stability. A free neutron is slightly heavier than that of a proton because it can decay to a proton, electron, and an antineutrino for a half-life of 12 minutes. Well, I won't get into all the aspects of that, but you get the sense the mass of a proton is exactly what it needs to be for the nucleus, for the atom to hang together. Okay, if the mass of a proton were increased by just 0.2%, it would decay into a neutron. The proton wouldn't last anymore. And a positron and a neutrino, this decay does not occur. If it did, hydrogen could not exist. And hydrogen is necessary for life. So because it's the dominant element of the universe, without that, the universe could not exist. So the mass of a proton is exactly what it needs to be to support life. Second, gravitational force. Like I said, if I step on this seat here, put my foot over it, I'm going down. And why is that? Is because the earth is pulling me down. So the mass of the earth is pulling me down. So there's a gravitational constant that defines that. The actual formula for that force, the gravitational force, is F, the force, gravitational constant G, times m, the mass of the earth, and m, my mass, divided by the distance between the two masses to the power of 2. And that power is 2.00000 as far as you can go. Why is it 2.000? Why isn't it 1.99 or 2.01? Gravity wouldn't work. It's got to be exactly a power of 2. So this is, again, evidence of essential design. And the strength of electrical charges, between positive and negative charges is exactly the same. It's 1/2, or this r squared in this circle here. Again, this r squared is 2.0000. And so it, again, is a very special constant. Okay, so now we talked about what does it take for a solar eclipse? What is a solar eclipse? Well, it's shown in this picture here. It's when the moon gets in between the sun and the earth, okay? And so it has to be, if the moon here were further away from earth, you wouldn't get an eclipse. And the only way you can get a total solar eclipse is because the sun is 400 times the size of the moon, and the moon, or the sun, is 400 times further away from the earth than the moon is. So all those ratios are exactly what they need to be. Anybody here seen a total eclipse ever? Seen the pictures of it, but yeah, I think we had a few come through here too. So you can see that is required. It has to be precisely that. So it's visible from a narrow track on the surface of the earth. And so there may be the path that it follows is maybe 100 miles in width, and that goes across the earth from one end to the other. So that is exactly the way it happens. So the sun's distance is 400 times the moon's distance. Sun's diameter is 400 times the moon's diameter. So total eclipse by design. And there you have what that can look like. Okay, so then we go to other universal fine-tuned parameters. There are specified at least 35 parameters for the universe to be exactly, they have to be exactly what they are in order for the universe to hang together. So these numerical constants and equations for gravity, electromagnetism, strong, weak forces, and for our galaxy, the solar system, the Earth, we have about 66 other parameters. So like the distance from the sun, if we were further from the sun, we would be a very cold planet and we couldn't exist. And so we are exactly where we need to be to support life. The size of the Earth, the temperature, of course we have ups and downs, but we can live in this range of temperature, and the rotation speed of the rotation of the Earth. If it were rotating faster, it would be too hot to support life. If it was rotating slower, by the time it came back around to us again, we would have been way too cold to survive. So it's exactly going at the rate it needs to support life. So the size, the temperature, the type of the sun, it produces energy and light just like we need it. So the size, the actual tilt of the Earth, rotation speed, the moon, composition of the Earth, the stability of Saturn and Jupiter, two gaseous planets which are protecting us. So the Earth has some very unique attributes. It's the only planet known to have plate tectonics, for example, that we know of. The strong magnetic field to deflect harmful radiation, which is required to protect us. It is tilted at 23.4 degrees to give us the 4 seasons. And remember that 70% of the Earth is covered with water. And that's very important because if it wasn't enough water there, we couldn't stabilize the temperature because the water holds the temperature as constant as it can for a long time. So it's the right distance from the sun to be liquid, because if it was too far, we'd have there'd be a frozen pond. And atmospheric pressure is just right. So it contains diverse living organisms and protective zone of layer of ozone. And the moon is at the right distance to induce tides. It's the gravity between the moon and the Earth that causes tides. And that, of course, helps to keep the water clean, because if we didn't have those tides, water would stagnate and become unusable. So all of these serve a purpose. Here's the tilt, which I'm sure you've seen that before, 23.5 degree tilt, and that allows us to have 4 seasons. So other Earth constants, 122 very narrowly defined constants identified to support life, and they're all exactly what they need to be. The oxygen level in the Earth's atmosphere, for example, 21% of the atmosphere is oxygen, and there's nitrogen and argon, But the important thing for life is oxygen. And of course, you can't have too much, or it'll also be susceptible to fire. And you can't have much less, or it wouldn't support life. So again, that's exactly what it needs to be. So the Earth's position in the solar system, our galaxy and universe, allows us to have life on Earth. The magnetic field protects us. The thickness of the Earth's crust controls the release of oxygen. The Earth's size, rotation, and tilt. Rotation of the Earth, rate of the Earth controls the temperature differences, which I just explained, and the tilt of the Earth. So what's the probability of all these constants being exactly what they need to be? 1 in the 10 to the power of 138. So that is so small that you can't conceive of a universe coming into existence by chance. The mathematical probability is 0 that this would happen by chance. It requires a designer to build the Earth. Jupiter and Saturn are gaseous planets. They're out further, much further away from the sun. And of course, they don't support life. But Jupiter and Saturn, they do protect us from radiation from other sources in the universe. Jupiter's role acts as a comet and asteroid magnet, shielding Earth from catastrophic collisions, because otherwise all that stuff could come to the Earth. Now, we've had some things hit the Earth, but nothing that has been really catastrophic. Our sun is located between 2 spiral arms. You can see that in the bottom chart there, the circle. The sun is at the bottom. Maybe you can't see that on this there, but it's on the slide. It's between 2 of those spiral arms, and it keeps us away from other serious conditions. So we, in fact, since we are in that area, it allows us, between the 2 spiral arms, it allows us to see much of the rest of the universe. If we weren't there, our view would be blocked. We couldn't study much of the universe if we weren't in the right place, and we are in the right place. So then unbelievers will say, well, okay, so we live on the right planet. How about other planets in the universe that might also support life? So what's the probability? Remember, we need to have those, the fine-tuned parameters need to be exactly what they are on Earth to support life. On any other planet, they would have to have those same parameter values. And you can see here the probability even for 80 fine-tuned parameters, 1 in 10 to the power 53, it's not possible. And if you have 128 fine-tuned parameters needed to support life on a planet, again, it's impossible. That 166 has to be less than 50. So then you look at, remember there are 100 billion galaxies out there, and each of those galaxies has 10 to the power 11, again, 100 billion stars per galaxy. If you multiply out some of those numbers, and then you say, well, every star, every sun, like we have our solar system, is not going to support planets. But if you take some probability, the upper limit for the number of stars in the universe, the number of galaxies, the percentage, and the number of stars, and you assume that there's 1 planet per star for those. Therefore, you have 10 to the power of 22 planets in the whole universe likely to be. So that's a pretty small number when you look at the other factors. So the number of planets suitable for life for 80 fine-tuned parameters is 10 to the minus 53 times 10 to the 22, if you assume that every galaxy has at least 1 planet, 1 star with a planet. So I'm not going to go through all the math, but to have all the parameters right, you can only get to 10 to the 144, and that has to be less than 50 to be able to support life. So the mathematical probability of there being another planet out there that can support life is zero. We really don't expect it to happen. So today, that's actually 20 years ago now, since 1996, over 500 planets have been identified outside of our solar system. Okay, that's a reasonable number. There are more now, but only 5% of those have any planets at all. And then the planets are either too large, too close to their star, or with too erratic an orbit to harbor life. So here we've identified some planets out there that seem to have some of the same characteristics as our Earth, but the possibility of supporting life, a few of the parameters are just wrong. There's no way it could support life. So the probabilities haven't changed. They're just getting smaller the more planets we find. Here's a scientist who says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency, capital A, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? In other words, was there a designer behind the earth that we live on here? Was it God who stepped in and so providentially crafted the cosmos for our benefit? And he did. He created this planet, and we are here. So as you look further, Professor Steven Weinberg, he says, life as we know it would be impossible if any one of several physical quantities, those 122 physical quantities, had slightly different values. Even if a few of them were slightly different, it still could not support life. So the chances are very, very slim. Fred Hoyle, another well-known astronomer, he finally has to admit that a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Here's a secular scientist agreeing that the possibility of there be another planet that life could exist on is almost zero. So what do evolutionists say about this? Evolution is unable to deal with such permanent properties of nature. Max Planck, he lived a number of years ago, a Nobel Prize winner, a founder of modern physics, stated, there is evidence of an intelligent order of the universe to which both man and nature are subservient. So here's one Nobel Prize winner. He says, this cannot happen by chance that we live on this earth. There's a designer behind it, and design supports creationism. So in summary then, Earth is our privileged planet. This is where we live. There are more than 100 unique physical constants, which are exactly what they need to be to support life. Some of you may have seen, there's a video out on called Privileged Planet. Two astronomers from the intelligent design movement in Seattle produced this, showing how privileged our planet is. And these are the two scientists that work for the Discovery Institute in Seattle who produced that movie. So they're concluding, of course, that Earth uniquely situated to sustain complex life, and Earth is uniquely situated to observe the universe. So we are the place between two arms of our spiral galaxy, so we can see much of the rest of the universe. Because if we were in the middle of one of those arms, there's no way we could see through all that, the maze to the rest of the universe. So we are privileged because we live on the planet that God created, and we live on the planet where we can observe the rest of the universe from. There's another video that has come out from the Discovery Institute recently, that is privileged species. So some scientists will say, well, look at the probability of a universe being such that we have the planet Earth that we can live on is very small. But if you consider there are multiple universes out there, an infinite number of universes, how they exist, we don't know. And so they come up with this explanation. Well, we just happen to got all the parameters right. It's by chance. But the probability is so small that really can't be a solution. There's a scientist, a UK scientist, Anthony Flew. So he has since passed away, but he wrote a book that there is no God. God does not exist. He was an English philosopher. But then when he started to see some of these design principles that we see, that we've been looking at here, he finally came to recognize there is a designer behind this. So then he wrote another book saying there is a God. So multiverse cannot explain it. He wrote, so the multiverse or not, we still have to come to terms with the origin of the laws of nature, and the only viable explanation here is the divine mind. And so we agree with that conclusion. He came to recognize that God exists, but we don't think he accepted Christ as his Savior at all, but he does recognize there was a designer behind it. So again, this is that DVD, that movie that exists, The Privileged Planet, and the new one, Privileged Species, put out by the same people. Okay, so that's a quick whirlwind tour of why we live on a very special planet that supports life, and we see no other explanation that it was designed by God. There's a retired mathematician, John Lennox, and he is a very dedicated, strong Christian, and he has debated with Richard Dawkins, who's also a well-known atheist, very many times, and he is a very good debater and defends the Christian worldview very well, if you ever have a time to do that. So again, we conclude the earth was designed for us, and God did that. Again, all of these, my messages that I've given here are on my website, and your pastor can show you where they are after we collect them all and point to them. So anyway, thank you for your attention, and I think if we have a few questions, we have time to take a few. Yeah. Microphone.
If we're in the universe, in the Milky Way, how do we get a picture of the Milky Way?
Say that again?
Good question.
If we're in the Milky Way, how do we get a picture of the Milky Way?
How do we picture?
How do we get a picture of it?
Oh, well, telescopes.
But
Okay.
we're in it looking out. How can we see?
But telescopes can look a long way. They can, the light is coming from, those stars, and scientists can interpret the signals from that. They can tell, which elements are predominant in different places. You saw that one picture of all the stars and galaxies.
Yeah, the whole Milky Way.
Yeah.
But
Well,
how,
You have to be outside.
we have to be outside looking in to get the picture.
yeah, well, that one was beyond the Milky Way.
Mickey, you're not a scientist.
I could be.
Yeah,
Conspiracy theorist, right?
All right.
so it's easier.
Don't cause trouble.
All right.
There are other stars in the Milky Way, right? Yeah. So we can see those because we can see beyond the Milky Way, to other galaxies, other stars. So we can certainly see, the stars in our Milky Way. Yeah.
There's a mirror.
So is there anybody think there's any probability that life could have, there'd be another planet out there that could support life?
You said
Yeah.
you had a question.
A lot of parameters have to be exactly what they are in order to support life, and the probability of doing that is
Last one.
approaching
Cut off.
0.
Okay, Colossians 1:17 says, "In him all things hold together." Colossians 1:17, "In him all things hold together." Is that, I've heard that applies to like the atoms, actually holding the atoms together.
Well, there's, you know, the electrons going around the nucleus, okay, they orbit, right, and the negative charge and the positive, you know, they attract. And so that, like the law of gravity, I mean, it's the electromagnetic force that keeps them together. Yeah.
I think if there was life, I think if there was life in another planet, that God would have talked about it in His Word.
God would show us?
God would have told us
Yeah.
in His Word.
Yeah,
Yeah.
yeah. But
And yeah.
yeah, but, you know, for us to even know that, you know, it takes many light years just to get back and forth. You got enough fuel in your rocket to, yeah, I mean, there's, you know, of course we can get signals, you know, they're looking for signals from outer space that have a message to go, but we haven't come across any meaningful messages.
Do you have more?
Back to what I was saying, God created the heavens and the earth and everything in it. So He put so much in His Word about our earth that He doesn't talk about other earth being able to hold life.
Right.
So that's why I have to stand on His Word that I don't believe that there's life anywhere else. I know there's always a possibility because not on my point, because I just said I believe that there's no other life. But God is a creator, so I don't want to think that He couldn't
Right,
do that.
yeah.
Okay.
Well, and we're not told in the Bible about any of that. You know, that's way beyond what we need to know even.
Anyone else? Anyone? Bueller? Bueller?
Yeah. Okay, so we'll wrap it up. I'll just close in a word of prayer. Remember, you know, we still have some books out there. There's you know, answers books from different creation ministries. You know, Creation Ministries International, ICR, and Answers in Genesis, and also some devotional books that we sell a lot of, especially at Christmas time, that have a daily devotional and have an example of you know, some of the stuff we're talking about here from all the different disciplines of science. That's done by Bruce Malone. He's one of our speakers. We're going to have him later this year come to visit us and speak with us. So let me close in a word of prayer and we'll be dismissed. Father, we just thank you for who you are, for what you've done for us. We thank you that you sent your Son on the cross to die for us. He rose again from the grave, and he makes salvation possible for us. And we thank you for that gift. We thank you for your creation. Thank you that we can study it. Thank you for all the scientists that have gone before us and have discovered much about what you have created for us to enjoy. And we just thank you for that. Pray that each one here will have learned something new that they could share with their friends, their schoolmates, their family, colleagues, or whoever you put in their path. And we just ask you that they use this information as well to witness to those people. In Jesus' name we pray. Amen. Thank you.